Hi YouTube, Tim Eckert here. In this video we're going to go through some solving some logarithmic problems. We're going to use power rule, a little bit of change of base, and we have to know a little bit about negative exponents. So let's get to it. So this first one, we have log base 4 of x to the 7th power equals 21. I'm going to rewrite that as 7 times the log with a base 4 of x. So I can take this exponent down and put it here. Set that equal to 21. I'm then going to divide both sides by 7. 7's here are going to cancel, and I'll get log base 4 of x equals 3. At this point, I can write this in exponential form. I can say 4 to the 3rd power equals x. So what is 4 to the 3rd power? Well, it's 4 times 4, which is 16, times 4 again, which is 64. So x equals 64. Okay, let's try another one. Problem 2 here, we're having log base 2 of x to the 8th power equals 56. So I'm going to rewrite this as 8 times the log base 2 of x equals 56. Then I'm going to divide both sides by 8. The 8's here cancel. I get log base 2 of x equals 7. So I can rewrite this as 2 to the 7th power equals x. So 2 to the 7th power is 7 2's multiplied together. So we have 2 times 2 times 2 is 8, times 2 again is 16, times 2 again is 32, times 2 again is 64, and times 2 again is 128. So x equals 128. Now here's the thing. Well, first off, that's a badly written 128. Let me try again. So 128. It's a little bit better. Here's the thing. So this exponent 8 here is even. And that means if x is negative, because I'm raising that to an even power, it's still going to be a positive result. And I can still take the log of it. I can't take the log of something negative. So long story short, x can also equal negative 128 here. Okay, let's try another one. Problem 3, we have the natural log of x to the 10th power equals 110. I'm going to rewrite that as 10. So I'm taking this exponent, moving it to multiply by the natural log of x. That equals 110. Okay, now I can divide both sides by 10. The 10's here cancel. I get the natural log of x equals 11. Okay, so natural log has a base of e, so I'm going to write e, when I write this in exponential form, e to the 11th power equals x. But again, we're raising to an even power here. So not only could x equal e to the 11th, right? It can equal e to the 11th. X could also be a negative e to the 11th. And it doesn't matter if negative e is inside parentheses or you have a negative one in front, it's going to be the same thing. When I raise it to the 10th power here, both of these are going to come out positive, and we're going to be able to do that. Okay? All right, let's look at another one. So we have the log of x to the 7th power equals 63. I'm going to rewrite this as 7 times the log of x still equals 63. Ooh, that 63 got away from me there. So still equals 63. I'm going to divide both sides by 7. 7's are going to cancel here, and I'll have the log of x equal to 9. Log has a base of 10, so I'm going to say 10 to the 9th power equals x. So x is going to equal a 1 with 9 zeros after it. So 1 billion. Now you could also see sometimes people they might just write x equals 10 to the ninth, or they might write x equals 1 times 10 to the ninth, or they might write it out with the zeros. Each of these represents the same value. So 10 to the ninth equals 1 times 10 to the ninth equals 1 billion. The power here we started with was an odd power, so we don't have a negative solution in this one. All right, next one, we have natural log of x to the fifth equals 25. I'm going to rewrite this as 5 times the natural log of x. That equals 25. We're going to divide both sides by 5. And we'll get the natural log of x equals 5. The base of a natural log is e, so when I write this in exponential form, e to the fifth power equals x. Again, we start with a 5 here, so it's an odd power, so we can't include a negative solution here. Next one, we have log base 7 of x to the sixth power equals 12. So I'm going to write this with the 6 in front, so I'm going to do 6 times the log, the base 7 of x equal to 12. We'll divide both sides by 6. We get log base 7 of x equals 2. Writing this in exponential form, we'll say 7 to the second power equals x. 7 to the second power is 7 times 7, which equals 49. So x will equal 49. But here's the thing, we're raising it to an even power. So x could also equal negative 49. And when we raise negative 49 to the sixth power, we're going to get a positive number for our output. And we can take the log of a positive number. So x could also equal negative 49. Okay, let's keep going. All right, this next one, we're going to evaluate the log base 32 of 8. So I'm going to use my change of base formula. I'm going to write this as log base c of 8 over log base c of 32. Now I want a base that's c such that I can multiply the number by itself enough times to get both 8 and 32. And the number I want to pick is 2. So log base 2 of 8 over log base 2 of 32. So how many times do I have to multiply, or how many 2's do I have to multiply to get 8? Well, if I do 2 times 2 times 2, that does give me 8. So that's 3 2's multiplied together will give me 8. And how many 2's do I have to multiply together to get 32? Well, 1, 2, 3, 4, and 5. So 5 2's. So my solution is 3/5. Let's keep going. All right, log base 6 of 216. So the way I like to think about evaluating these type of problems is I want to think of how many 6's do I multiply first to get 216. So 6 times 6 gives me 36, times 6 again gives me 216. But I have 1 over 6, or 1 over 216, so I need a negative exponent. So instead of a positive 3 for my solution, I'm going to have negative 3 for my solution. Let's keep going. Okay, problem 9, we have the natural log of 1 over e. So when we're asked to evaluate this, we're saying e to what power equals 1 over e. Well, e to the negative 1 power equals 1 over e. So this evaluates to negative 1. All right, let's try one more. So evaluate the log of 1 over 1,000. So log is base 10, so we're saying 10 to what power equals 1 over 1,000. We have 3 zeros, so I could write that as 1 over 10 to the third power. So we have to have a negative exponent here for it to be positive in the denominator. So this has to be negative 3. So this evaluates to negative 3. Hopefully you found this video helpful. If you did, please like and subscribe.